Examples on how to use the quotient rule. So firstly, we recall the quotient rule. Derivative quotient equals derivative numerator times denominator minus numerator times denominator over denominator squared. Say we want to take derivative of x plus 1 over x plus 2. According to this rule, I'm going to write on the scheme. And the scheme will look something like this. Derivative numerator times denominator minus numerator times derivative denominator over denominator squared. So now I'm going to fill it up. X plus 1 for numerator, x plus 2 for denominator. Okay. So I keep x plus 2 squared on the bottom. Derivative of x plus 1 is 1, so x plus 2 times 1 minus x plus 1. Derivative of x plus 2 is 1. So all that is left now is take x plus 2, distribute minus x plus 2 squared, distribute minus x minus 1, combine like terms. X minus x is 0, 2 minus 1 is 1, so final answer is 1 over x plus 2 squared. So let me try to do maybe one more example on the quotient rule. Say I want to take the derivative of x cubed divided by sin x. I'm writing scheme for quotient rule. Derivative numerator times denominator minus numerator times derivative denominator over denominator squared. So going to write down x cubed for numerator, sin x for denominator. Derivative of x cubed is 3x squared. Derivative of sin x is cosine x over sin x squared. So that's how approximately a quotient rule might go. And maybe just one more quick example. Say you want to take derivative of 1 over x cubed. It's actually easier to take derivative of 1 over x cubed using the negative exponent. So sometimes, if it's possible to avoid the quotient rule, try to avoid. So you switch to negative exponent. You get negative 3x to negative 4. You get negative 3 over x to 4. So let me try to do the same problem, but now using the quotient rule, and see that's slightly more complicated, but still you should be able to get the same answer. So we're still taking derivative of 1 over x cubed, and somehow we didn't realize that we can switch to negative exponents. So we're writing down the scheme for quotient rule. 1 for numerator, x cubed for denominator. Derivative of 1 is 0. Derivative of x cubed is 3x squared. X cubed squared is x to the 6. So you get negative 3x squared over x to the 6. X squared and x to the 6 can be reduced into x to the 4 on the bottom, and we keep negative 3. So we get exactly the same answer. It looks like a little bit more calculations.